Hello, ladies and gentlemen. 2-7 solving rational equations. This is the last thing in the unit, which means it's the last thing in the semester. It's hard to believe, but that's where we're at. So, we're going to use a lot of the skills that we used in the previous lesson where we were just simplifying things. But first, I want to go through this and do some of the easy ones. So, let's do some easy ones here. When you have one fraction on the left and one fraction on the right, this is a proportion. You can cross multiply, so I'm going to multiply x times x minus 1 and 4 times 5, which is 20. So x squared minus x, I'll move this 20 over to the other side, so I'm subtracting 20 as well as distributing. Then when you factor, that's x minus 5, x plus 4. So x could either be 5 or negative 4. Or could it? So when you're doing rational equations, you need to check for extraneous solutions. So if I plug 5 in, do I get 0 in the denominator? No. If I plug negative 4 in, do I get 0 for the denominator? No. What you just need to realize is that 1 is not in the domain. So if you would have gotten 1 as an answer, that's called an extraneous solution. These, yeah, they both work. They're fine. So let's do another one. X times x squared equals 9 times 4 is 36. Square root both sides. And you got to remember this. When you square root, you got to do plus or minus. So it's plus or minus 6. Or does it? Yeah, it's not 0, so you're fine. One more. 4x equals 5 times x minus 3. 4x equals 5x minus 15. I'll add 15. I'll subtract 4x. X equals 15. That's in the domain. But had I gotten 0 or 3, then I would have said extraneous. So I keep saying this, but it hasn't happened yet. We're going to do this problem a couple different ways. I want you to understand that either way is algebraically the same. I can tell you how we have more success, and then I'll show you sort of the way to do it that's like, if you're a pro, you can kind of do it in your head. So the way that I think most of the time we have success is if we get every term in the problem on both sides of the equal sign. So the entire equation has the same denominator. So I'm going to find the least common multiple between 3, 6, and 4, which that would be, if you want to just play the common multiple game, I'll list factors, or no, multiples of 3. I'll list factors of 6, and I'll list factors of 4. And kind of, you should definitely be able to do this in your head to realize that 12 is the least common multiple. Okay? So we're going to make all these denominators 12. Now, this 2/3 x, just so you understand, that's the same as 2x over 3. It is not the same as 2 over 3x. X is implied to be in the numerator. It's over 1. So I'm always going to write this as 2x over 3. So I have 2x over 3 plus 1 over 6 equals 3 over 4. I want to get a common denominator for all the denominators. So that's 12. I'm going to multiply this guy by 4. But if you do it in the bottom, you have to do it in the top. I want to multiply this guy by 2, and I want to multiply this guy by 3. That way, all my denominators will be 12. So this is now 8x over 12 plus 2 over 12 equals 3 times 3 is 9 over 12. Now that everything is over 12, what you can do is multiply both sides by the least common multiple. I'm going to multiply both sides by 12. And when you do that, and then you distribute that 12 times 1 over 12, those cancel out, and those cancel out. And now we have 8x plus 2 equals 9. We took care of the whole denominator this way. So 8x equals 9 minus 2 is 7, which means x is 7/8. Okay, that's it. Get a common denominator for everything, and then multiply both sides by that denominator. Now, some of you might be saying, why do I have to do that if I can just do it in my head? And you're right, you can. Right at the beginning, just multiply both sides by 12. If you're really like, I can do this in my head, fine. Then you should be able to do this and say, okay, 12 divided by 3 is 4, and 4 times 2 is 8, so now it's 8x. 12 times 1/6, or 12 divided by 6 is 2, and 12 divided by 4 is 3, and 3 times 3 is 9, and you get the same equation faster, but I'm just telling you, when you get a lot of polynomials, it usually doesn't go as well. So my suggestion will be, do it how the first way. Get everything over the denominator. That's how I'm going to do it for all the problems that we do today. So first thing, I want a common denominator for all of these terms. Now, these have x minus 2. That's nice, but this guy's got a 5. So what I'm going to need to do is get them all to have the same denominator. So I have x, let's see, x over x minus 2 plus 1 over 5. I'm going to just leave myself some room to work. So my denominator is going to be their product. If you're looking for a common denominator, you can always multiply them together. In this problem, that's all you can do. So this guy needs a 5, and this guy needs an x minus 2. And my denominator will be 5 times x minus 2. This guy also needs a 5. So now that I have everything over that denominator, sometimes in Algebra 2 you might have seen something where we'll say like LCM on both sides, multiply both sides by the LCM, the least common multiple or the least common denominator. I don't really like that. It's not bad. I just like to say I'm actually going to multiply by the denominator. So I prefer to actually write it out so that you understand really what you're doing. These all cancel out though. So now in the numerator, that's all I'm looking at. I'm just looking at the numerator. So that would be 5x plus, now we have to distribute, well, you have to distribute a 1, so it's just x minus 2 equals 5 times 2 is 10. Now look how easy it is. 6x minus 2 equals 10. Add 2 to both sides. 6x is 12. Divide both sides by 6. X is 2. Or is it? When you try and go back, you need to test to see if this actually works in the original problem. If you plug in 2, uh-oh. If I try and plug in 2, then I get 0 in the denominator. 2's not in the domain of this, which means this is not a solution, and that was the only solution I got. There's actually no solution to this problem. There is no solution, because the only solution that we have is called extraneous. So you could say 2 is extraneous. It's an extraneous solution. It's a solution that doesn't solve the original equation, so we call it extraneous. It solves this equation. It doesn't solve this equation, if that makes sense. Let's try another one. All right, so this is a little more complicated. 4 over x minus 1 plus 1, I'm going to write 1 over 1, equals negative 10 over... Now, if you see a denominator, you want to factor that. Now, this is a 1x squared, so it's what multiplies to 8 and adds to negative 9. That's x minus 8, x minus 1. The reason we factor any denominator that we can is because it helps us figure out sort of what each factor is made up of, which makes it easier to tell what each factor might need. Because now I see that they share an x minus 1, but this guy still needs an x minus 8. This guy has no denominator, so it's going to need the whole thing. X minus 1, x minus 8, x minus 8, x minus... I said it backwards, but I wrote it the same. There you go. So it needs the whole thing. Now that everything is over the same denominator, we can multiply both sides by x minus 1, x minus 8. Which remember, if you do it to both sides, you're allowed, that's fine. As long as you do it to both sides, you're good. So all these denominators cancel out, and now we're just looking at the numerator, which is so much nicer. So I'm going to distribute 4x minus 8 times 4 is 32 plus. Here I'm going to FOIL. So look, it's right there, okay? This is the factor form. There's the expanded form, so I know it's x squared minus 9x plus 8, but you can FOIL it if you really feel like it. And then on the right side, I didn't have to do anything with the numerator, so it's just negative 10. So it looks like we got a quadratic. Oh no, we have to solve a quadratic. That's fine. X squared 4 minus 9 is negative 5x. Now, I'm going to do this. I'm going to add 10 to both sides as well. So I'm going to say plus 10 plus 10. So this is 18. 18 minus 32 is going to be 18. Wait, did I say that right? 18 minus 32. So yeah, minus 14. Okay, equals 0. Cool. So I got x squared minus 5x minus 14. That's factorable. Fine. Easy. What multiplies to negative 14 and adds to negative 5? X minus 7. X plus 2. That means my solutions are at 7 or at negative 2. Maybe. If you kind of think about it at the beginning, the things that are not in the domain, x can't be 8. X can't be 1 because of these denominators. So x can't be 8, x can't be 1. We didn't get either of those, so these are both solutions. These are actual solutions to the equation, not extraneous solutions. They're actual solutions. So the main thing is get a common denominator, clear the fraction, and then solve the numerator. Let's do a few together, and then you guys can work on your math lab. You have, I don't know, 5 or 6 to do for practicing your math lab. So I'm going to go 3 over x minus 3 plus 1 over x plus 3. And I got a feeling this is going to work out pretty nice because that is x plus 3, x minus 3. So what's this guy need? He needs an x plus 3. What's this guy need? X minus 3. What's this guy need? He's got everything. We're good. Now, every denominator is x plus 3, x minus 3. So like I've been doing, I like to write it out. I'm multiplying both sides by x minus 3, x plus 3. So these cancel, 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 cancel. All that goes away. Now, we're just looking at the numerator. So for the numerator, I'm going to distribute 3x plus 3 times 3 is 9 plus 1, distribute 1, you just get x minus 3 equals 14. It's linear. It's about as easy as they get. 4x plus 6 equals, whatever, 14. 4x plus 6 equals, no. What's happening? Yeah, that's fine. Okay, maybe I was writing up 14. Anyway, 4x plus 6 equals 14. I will subtract 6 and get 4x equals 8, which means x equals 2, which is fine. X can be 2. X can't be plus or minus 3. But x can be 2, so that is the solution. Let's keep going. 3 over x plus 2 minus 1. Okay, minus, you got to be a little careful here. This can mess with you. Factor, x minus 5, x plus 2. So what do we need? This guy's got an x plus 2, needs an x minus 5. This guy needs everything. Top and bottom. This guy's got both, so we're good. Now, again, clear the fraction. So I'm going to multiply both sides by the least common denominator. Well, I guess it's just the common denominator. X minus 5, x minus 5, x plus 2. Now they all go away. Bye. All right. So now we're just looking at the numerator. So I'll distribute again. 3x minus 15. Now this is a minus. We know what it is when you expand it. But we're subtracting it because it's negative 1 times that. So it's going to be minus x squared, but then it's going to be plus 3x and plus 10. Because you have a negative 1 on the outside of this quantity. This is the same thing. This is the factored form. This is the expanded form. I'm just distributing a negative 1. So it'll be negative, positive, positive. Negative, positive, positive. And on the right side, I have just negative 5. So we got another quadratic. Let's combine like terms. 3 plus 3 is 6x, and negative 15 and 10 make negative 5. I don't like when the x squared is negative, so I'm going to move everything to the other side. So now it's positive x squared, negative 6x. When you add 5 to both sides, you actually get 0. So it's plus 0, which I'm not going to write. You just get 0 on the right side. Now, people will get to this step and then melt down, and that's very frustrating because this is about as easy as it gets. You're just stuck in, I have to factor something, a trinomial? It's not a trinomial. What do? You just do GCF. The GCF is x. X minus 6. You're still solving by factoring. It's just a GCF problem, so it's easier. You want to know when each factor equals 0. That would be at 0 or at 6, maybe. What is not in the domain? Negative 2 and 5. So these both work. Cool. 0 and 6. All right, let's do a couple more. So 1 over h plus 3 plus 2 over h equals 3 over h plus 3. Looks like their product is going to just be the denominator I need. So this guy needs an h. This guy needs an h plus 3. And this guy needs an h. Now that everything is over that denominator, I will clear the fraction by multiplying both sides by h times h plus 3. h plus 3. So all these go away. Cool. What's in the top? That's all I'm looking at now. It's just the top. 1 times h is h. Distribute 2h plus 6 equals 3h. So on the left side, I have 3h plus 6, and on the right side, I have 3h. Okay. So we'll subtract 3h on both sides. And we get 6 equals 0. What? 6 equals 0? Sweet math, bro. No, it doesn't. This is not true. And this happens. Sometimes when you're solving equations, there's no solution. There is no solution to this problem. The reason I know that is because at the end, I got a false statement. 6 does not equal 0. It's never going to equal 0. There's no variables in there to help me. 6 just doesn't equal 0, so there is no solution. The other thing that every now and then happens is, let's say I solve this and at the end I got like 6 equals 6. And you're like, cool, 6 equals 6. Yeah, that's always true. And when that happens, then what you're dealing with is the same expression on both sides. That's in all solutions. So if you get a false statement, that means there's no solution. And if you get a true statement, this is called a tautology, it's always true, then there is infinitely many solutions because it's the same thing on both sides. It's just maybe different form. So this one's no solution because all the variables canceled out and you got a false statement. Okay, one more. Last one. So I have 6x over x plus 4 over 1, and then 2x plus 2 over x minus 1. So I'm going to multiply their denominators together. That means this guy needs an x minus 1. This guy needs both x plus 4 and x minus 1. And this guy needs an x plus 4. Okay, this is a little bit more work. I got a FOIL a couple times. All right, that's big time. But the numerator is going to go, or I'm sorry, the denominator is going to go away because I'm going to cancel it out. I don't want to deal with any of that. So this all is going to go away, all my denominators, by multiplying both sides by x minus 1, x plus 4. I keep showing you that because I don't want you to think I'm just doing some magic trick or I'm just ignoring it. I'm algebraically canceling it out. It's gone now. Now I have the numerator. So now I have to distribute. So this will be 6x squared minus 6x. I'm going to do this in 2 steps. So first, I'll simplify this. X squared minus 1 plus 4 will give you plus 3x, and then minus 4. And on the right side, I have to FOIL as well. So 2x squared, 8x and 2x make 10x, and 4 times 2 is 8. The reason I do that, I'm going to handle the 4 at the end. It's not the only way to do it. You could distribute the 4 at the beginning and then distribute. It doesn't matter. I just find that I have the most luck when I ignore that until the end. So let's see. I got 6x squared minus 6x. Now I have to distribute the 4. So 4x squared plus 12x minus 16. We got a lot of terms here. That's okay. So let's get all our like terms on one side. I'm going to subtract 2x squared. So that's 6, and then that's 2. So 6 plus 2 is 8x squared. I'll subtract 10x from here. So that's negative 6 and positive 2, which is negative 4. And I'll add or subtract 8, negative 16, and negative 8 make negative 24. So I have 8x squared minus 4x minus 24 equals 0. We're going to solve by factoring. Work smarter, not harder. If you know all the multiples of, or all the factors of 8 times 24, what is that? 160 and 32. If you want all the multiples of 192, great. I don't. I'm going to GCF this bad boy. I got bring out a 4. 2x squared minus x minus 6. It's not red. I don't like that. There we go. So first just factor out the 4. And realize 4 is never 0, so I really don't care about that anymore. It's not affecting my zeros. It just affects like the graph. Don't care about the graph. I want to know the x-intercepts and that's it. So now I'm going to split the middle here, so it's a little bit harder to factor. What multiplies to negative 12 and adds to negative 1? That'd be negative 4x and positive 3x. So 2x, x minus 2, plus 3x minus 2. So I have 2x plus 3, x minus 2. Yeah, the 4 is out there, but it's never going to be 0. So what are my x-intercepts? Negative 3 over 2, or positive. I should call them zeros probably. Negative 3 over 2. X equals 2. Are either of those extraneous? Nah. 1 and negative 4 are the values that are not in the domain. These are both in the domain. So we have 2 solutions. Awesome. All right. That's it for solving. So your solving rational equations is very similar to simplifying. You just kind of go a little bit further. Now, you have a math lab over both of those. Well, I think the simplify might be on school issue. But you have a math lab for solving. Go ahead and get that done. You're going to have a practice test and a crash course you can do to review for the test, but your test is going to be at the end of the week, next week, right before break. And don't forget, you also have that extra test, the review assessment. We're not doing a final exam, but if you need a test grade, you can do that, and I will give you that as a test grade, which could be very beneficial for some of you guys. So go ahead and get all that done. Have a good day, and hit that like and subscribe button.